So they are perpendicular to each other. Now in the next, we see that waves in a spring, that if we move the spring in a push and a pull motion, then the wave direction is shown by an arrow and the push and pull is forward and backward. So the spring coils moves parallel to the direction of the wave. Okay. Now next, what we have studied up to now is that there are two types of waves. Number one is transverse wave and the other is longitudinal wave. Let's see how they are going to differ from each other. Now the transverse waves, if you move your hand in such a way that hand moves up and down, then the coil moves up and down while the wave moves from left to right. The movement of the coil is perpendicular to the wave motion. The transverse waves are the waves that travel perpendicular to the direction of the medium's vibration. That is electromagnetic waves. Okay. Next, if you see, we move the coil left and right, forward and backward. The movement of coil is parallel to the direction of motion. You can see in the arrows in the diagram also. Both arrows are in same direction. It means they are parallel to the direction of medium, and the example of longitudinal wave is sound waves. Now, the next is that what are the properties of longitudinal waves? In longitudinal waves, the part where the particles of the matter are closer together is called compression. The part where the particles are spread apart is called rarefaction. Longitudinal waves are formed by series of compression and rarefactions. Okay. Now we can see that if we see that the question is describe and explain the motion of by a styrofoam ball, if any, when the rod is dipped quickly into the water and then removed. Now if you dip the rod in water, the styrofoam balls will start moving up and down. Now again it's showing the transverse waves. Water always produces the transverse waves. Okay. Now what we have studied up to now, that what is a wave, and there are two kinds of wave, that is transverse and longitudinal wave. Now our second part of the lesson is that we have to define the properties of the waves, that is speed, frequency, wavelength, period and amplitude. And we have to state what is meant by the term wavelength. And we have to apply the formula V is equal to F lambda. That is very important to all the situation solving problems. So let's do it. First property of the wave, as you can see the diagram, see the diagram carefully. There is a dipper in the diagram that is moving up and down. It's a spherical dipper. When this dipper is spherical, it will produce the circular waves. Okay. The circular waves, the direction of the waves is like this, that the waves in circular direction, and the arrows shows the wavefront. Wavefront is a line that joins all the peaks of a wave or all identical points on a wave. Now the other part is shown. Now we will discuss the properties of the wave by seeing the diagram. See the diagram, there are points P, Q, R, S, T, U and V. The points P, S and V, they are the crust points, and R and U, they are the trough points. Crust are the highest points of a transverse wave and troughs are the lowest points of a transverse wave. Okay. Now next is about what other properties are about the amplitude, wavelength and frequency. Let's do it. The amplitude, see the diagram. The amplitude is the height of the crust or the depth of the trough. It is the maximum displacement of a point from its rest position. As you can see from the diagram, the red arrows shows the amplitude in both crust and the trough. Now let's discuss that what is meant by the points are in phase. The points along a wave are in phase if they have the same direction, same speed, same displacement from the rest positions. As you can see from the diagram, P, S and V all are the crust points. So they will move with the same speeds, they are in the same displacement, they are moved the same direction, so they are in phase. And R and U, they are the phase, and Q and T, they are in phase. Now, what is wavelength? The wavelength is the shortest distance between any two points in phase. Now, the P and